Today we're going to be looking at question 5 of the 2022 Maths Higher Level Paper 1 paper. So, question 5, bit of calculus and then a bit of algebra and we're dividing in. Part A, g of x is equal to x squared minus 1 over x, where x is a real number. Find g prime of x, the derivative of g of x. Easiest way to do this is we're going to have to rewrite this up here. If it was just 1 over x, or the negative 1 over x that we were looking for, we could just use the quotient rule. But because we have this x squared in front, I find it's much easier just to rewrite this. So what does it look like when we rewrite it? So we have g of x is equal to the x squared, we can't do anything with that. Now, minus 1 over x, anytime we have a number, so take the number 2 for example, and we raise that to a negative power, so in this case minus 1, this is equal to 1 over 2. Or technically this 2 is to the power of 1, because whatever the power here is, that's what the bottom number gets raised to. So in this case, we have x to the minus 1, which is equal to 1 over x, and then we just have to remember to put that minus sign in front of it. So we're going to have x to the negative 1, which is the same thing as the negative 1 over x. So we have minus x to the negative 1. Now, all we do is just use regular differentiation. So decrease the power by 1, multiply by the whole power. G prime of x is equal to 2x minus, same thing happens here. We have x minus x to the minus 1, so we still subtract 1 off of it, so it's x to the negative 2, but we still have to multiply by that whole power. So if I multiply this by negative 1 again, what we're going to have is a minus minus, because we have one minus here, and we have a second minus right here. So in the end, what this simplifies to is going to be 2x plus x to the negative 2, and again, if we rewrite this again, we have 2x plus 1 over x squared, because again, whatever the negative power is, that's what power we raised the bottom number to. So question 2, f of x is equal to 2x cubed minus 21x squared plus 40x plus 63, where x is a real number. X plus 1 is a factor of f of x. Find the three values of x for which f of x is equal to 0. Quick things to spot. It tells us that x plus 1 is going to be a factor of f of x. Wherever you see this in the leaving cert, if it tells you that it's going to be a factor, we're either going to be subbing in the result for that. So in this case, we have x plus 1 equals 0, so x equals negative 1 when you take 1 from both sides. If we stick negative 1 back in here, and all the x's in the equation get replaced by negative 1, what we're going to have is 0. That's what a root is. So we can also divide by the root, and that's going to allow us to find the other two roots. So in this case, we have x and 1. We're going to use the box method, and we start off with the 2x cubed. 2x cubed divided by x goes in 2x squared times. What's the difference between 2x squared and negative 21x squared that we have up here? Well, that's going to be negative 23x squared. Same again, negative 23x squared divided by x, we just end up with negative 23x. What's the difference between negative 23x and 40x? Well, it's plus 63x. Same again, divide this by x, we just have plus 63. This is the box method. If you want to do the long division way, it's entirely up to you, whatever you feel more comfortable with. It doesn't matter what your teachers are telling you. If it seems easier to you to do it and it's the correct way to do it, you may as well just go do it, because at the end of the day, it's your leaving, so that matters. So in the end, what we're going to have is that when you divide f of x by x plus 1, we have 2x squared minus 23x plus 63. So we take these three bottom numbers here. Now, when we divide a function by one of its factors, it'll give us the other roots. In this case though, it's giving us a quadratic. So we have 2x squared minus 23x plus 63. You can factorize as normal if you want. So you could find the factors of 2x squared, so it's 2x and x, and you could find the factors of 63. In this case, because I know it's going to be 9 and 7, that's what I'll write down. And now we just need to find some combination of multiplying, adding, and subtracting these numbers to get to what we want. So if we have 2x here, we're going to have the x here, and then you can trial and error it. The more comfortable you get with these and the more you do them, you're able to realize which one is actually going to be the proper method. So I know that if I times 7 by 2 and then add 9, I'll get to 23. And because this final number is positive, as in this one right here, and the middle number is negative, I know that I'm going to have to do two minus signs. So I'm going to have 2x minus 9x minus 7. If you want, just so we know that this is definitely correct, you can go ahead and multiply it out. So we get 2x squared minus 9 by minus 7 gives you plus 63. minus 9x, minus 14x, minus 23x, which is the exact same thing. So my other two roots are going to lie at 2x minus 9 equals 0, 2x equals 9, x equals 9 over 2, which is the same thing as 4.5. And my other root, well, that's just x minus 7 is equal to 0, so x is equal to 7. So in the end, I now have my three roots. I have my 4.5 here, I have my 7, and then up the very top, it told us that x plus 1 is equal to 0, so I know that x is negative 1, and now we just need to write them down. So we know that the roots of this equation happen at minus 1, 4.5, and 7. Any questions, just stick them down in the comment section below and I'll get back to you as soon as I can. Now, find the range of values of x for which f prime of x is negative correct to 2 decimal places. So the original function, f of x, if we scroll back up, we know that that's going to be 2x cubed minus 21x squared plus 40x plus 63. So this is a cubic equation, and it's a positive cubic equation. So we know whenever we graph it out, this cubic is going to look something like that, where you have your x-axis and your y-axis, wherever. What happens when we differentiate this? Well, if we differentiate this, first of all, let's see what we get. So we find f prime of x, that's going to be equal to 6x squared minus 42x plus 40. This is just regular differentiation, so I'm decreasing the power by 1 and multiplying by the L power. And what we have now is a quadratic. But what form do quadratics take? Well, first of all, it can either be positive or negative. If it's positive, it's U-shaped. If it's negative, it's N-shaped. We graph this out. Just a rough sketch. This doesn't exactly have to be what the function looks like. We're going to have something that looks like this. And we're looking for where it's negative. So if we're looking for where it's negative, what we're actually looking for is where it's going to drop below the x-axis. So we're going to get a negative y value. Because when you're dealing with functions, whenever you plug in a value for x and it gives you any number, that's going to be the corresponding y value. So in this question, what we're actually looking for is the roots of the quadratic equation. Because this point here and this point here is exactly where it drops below the x-axis. Once it drops below the next x-axis, we can get at what we're looking for, and that where f prime of x is negative. So let's go ahead and solve this. You can factorize it, throw whatever way you want. When in doubt, just stick to the minus b formula. You'll get the same answer either way, even if you could find the factors of it. So here we're going to have minus 42, because we have our b, a, and c. So we have minus 42 is just 42, plus or minus the square root of b squared. So you have minus 42 squared minus 4 times 6 times 40. All over 2 by a, which is 6. Bring this out, make sure that's square rooted. And this is how we're going to get two answers. When we figure this out, when we find out what happens when you use the plus and the minus, what we get is for the minus, rounded to 2 decimal places, is 1.14. And when we use the plus, rounded to 2 decimal places again, is 5.86. And I'm rounded there because exactly up here in the question, it asks for 2 decimal places. So what does this mean? That means if we look at the graph, right here is the point 1.14, and right here we have 5.86. So x anywhere in between these two is going to be negative, or it's going to give us a negative value, otherwise the function is going to be negative. So how do we write this out? Well, we take our x, and it has to be strictly less than 5.86, and it has to be strictly greater than 1.14. Why am I using strictly and not less than or equal to? Well, if it's equal to, it's going to equal 0. 0 is neither positive nor negative, although technically we always consider it to be positive. So if we were to stick in 5.86 into our f prime of x and we got a value of 0, technically it's not correct. If it's 1 decimal place less than it, even if it's 1 billionth of a decimal place less than it, it's still going to be a negative value. So that's going to round off that question there. Any questions, as always, just stick them down below and I'll get back to you as soon as I can.